Okay, let's talk about the trig. Let's talk about number 11 and 12. So, on number 11, you're going to need to fill out that like table of values in less than 5 minutes. And look, here's some things you got to do. You have to memorize your sine, cosine, and tangent, at least for quadrant one. Okay, so sine of 0, you got to know that that's 1/2 root 2 over 2, root 3 over 2, 1. Cosine is the reverse of that. So it's on you to get this memorized, right? And then tangent, like tangent starts at 0, and tangent, I was draw it backwards, but tangent is this increasing function. So you start with root 3 over 3. I think root 3 is like a 1.7 or something, and if you divide that by 3, you get 0.5 something. So 0, 0.5 something. Remember, this is sine over cos, so anything divided by itself is 1. And then this one ends up being root 3. And this one ends up being sine over cos will be undefined there. So memorize this. Okay? Straight up, you're going to know that. You got to know our reciprocals. 1 over sine is the same thing as, this is called cosecant x. This is the one that I remember. 1 over cos is secant, because it's almost cos spelled backwards, except the is the E in the middle. Right? C-O-S, S-C. And then 1 over tangent, most people remember that as cotangent. Okay, great. Memorize those. That's no problem. But what we really need to know is the reciprocals of all this stuff. So, like, what are the numbers here? We have to know 0, 1/2. We'll need a reciprocal of root 2 over 2. We'll need a reciprocal of root 3 over 2. And we'll need a reciprocal of 1. Oh, and the tangent values will also need a reciprocal of root 3 over 3. And we'll need a reciprocal of root 3. Okay, reciprocal of 0, undefined. Reciprocal of 1/2, 2. Notice I'm not using equal signs. These aren't equal, they're reciprocals. Reciprocal of root 2 over 2. Hey, y'all, it's root 2. Just remember that. I can do the math on this. If I want the reciprocal of this, I get 2 over root 3, multiply top and bottom by root 3, and then you end up with 2 root 3 over 3. And then never do that math again. Just memorize it. The reciprocal of root 3 over 2 is 2 root 3 over 3. One thing that helps me remember this is it doesn't simplify, because sometimes I'm like, wait, is it 2 root 3 over 3 or 2 root 3 over 2? It has to be 2 root 3 over 3, because it won't simplify anymore. Reciprocal of 1 is 1. Reciprocal of root 3 over 3, well, it's root 3. Reciprocal of 3, root 3 over 3. Oh, I put equals, not equals, just reciprocal. Okay? These are going to be important, because if I have all of these memorized without having to stop and do the math, then figuring out my trig values goes a lot faster. Then it's important to know how the quadrants work as far as the radians. In quadrant 1, the radians all have a numerator of 1 pi. So that's quadrant 1. In quadrant 2, all the numerators have the multiplier is 1 less than the denominator. So, right, 2 over 3, 3 pi over 4, 5 pi over 6. And notice that everything from here to here is less than, if you don't look at the pi, all the fraction parts are less than 1. To me, this is like the equator. Everything around here, if you don't look at the pi, the fraction values are greater than 1, right? 7 over 6, 5 over 4, 4 over 3. And then for quadrant 3, the numerator is 1 less than the denominator, or 1 more than the denominator. For quadrant 4, it's like it's almost 2 times the denominator, but not quite. So like 11 pi over 6, well, 12 pi over 6 would get you 2, but it's 1 less, 11. 8 pi over 4 would be 2 pi, but we're not quite there yet, so we're 7 pi. 6 pi over 3 would get you 2 pi, but we're not quite there yet, so it's 1 less, it's 5 pi over 3. Okay, so that helps me remember what quadrant, but you got to be quick with knowing what quadrant the fractions are in or the radians are in. And then whatever way you choose to remember this, I do all students take calculus. In quadrant 1, all the trig values are positive. Quadrant 2, only sine and its reciprocal, which is cosecant, are positive. Quadrant 3, only tangent and cotangent, which is the reciprocal, only those values are positive. And in quadrant 4, only cosine and its reciprocal secant are positive. Ooh, that's my crash course. You got to know, if you got all this learned, you get all this right here, this page, and you can rewrite this whole page really quick, then you're on your way. And then you got to fill out this table of values in less than 5 minutes. Well, here's the thing, no problem. Okay, again, make sure when you start that you have sine, cosine, and tangent memorized. Now, it's important to know that I put sine and cosine in this order, sine, cosine. Sometimes that confuses kids because on the unit circle, cosine is the x value and sine is the y value. But I do that on purpose, and I'll show you why in a minute. I don't really care which one you fill in first, but you should have these good to go. So sine, 0, 1, 2, 3 over 2 over 2 over 2 with the square root, and a big 1. 0, 1, 2, 3, big 1. And then these are like reflections. So it'll be 3, 2, 1, 0, over 2, over 2, over 2. Notice we're in quadrant 2 here. Right? And sine is positive in quadrant 2, so I'm going to leave that. Cosine, we start at 1, and we work our way down to 0. So 3, 2, 1, 0, over 2, over 2, over 2. With a square root, everything's positive here. And this is going to be a reflection, so it's going to go 1, 2, 3, 1, and over 2, over 2, over 2, square root. Cosine is negative in this quadrant, so I put in those negatives. The reason I put tangent here, I'm supposed to memorize tangent, but it helps because it's sine over cos. So sine over cos, that's 0. This is 2 root 3 over 3. And this is, look, anything divided by itself, 1. And this is, oops, why did I write 2 root 3 over 3? Sorry, this is root 3 over 3. Right, so tan 0, root 3 over 3, 1, root 3. Sine over cos, undefined. This also reflects root 3, 1, root 3 over 3, and 0 over 1 is 0. And we're negative here in quadrant 2. Cotangent. It is the reciprocal of tangent, yes? So reciprocal of 0 is undefined. Reciprocal of root 3 over 3 is root 3. Reciprocal of 1 is 1. Reciprocal of root 3 is root 3 over 3. And here's where I think, oh, it's 0 over 1, cos over sine. So that's 0. And then reciprocal here is root 3 over 3. And again, we're reflecting the values even though we're negative. Negative 1, negative root 3, and undefined. Okay, and then just make sure tangent starts small and gets bigger. So make sure your root 3 over 3 is first here. Cosecant. Cosecant is 1 over sine. So reciprocal of sine. 1 over 0, undefined. Reciprocal of 1/2 is 2. Reciprocal of root 2 over 2 is root 2. Reciprocal of, here it is, root 3 over 2 is 2, root 3 over 3. Reciprocal of 1 is 1. We stay positive here, and that's 2 root 3 over 3. We check if we have like this reflection going, and we do. This would be root 2. This would be 2, and this would be undefined. And then I check for my reflection. Got it. The other thing I'm noticing, look at these two undefineds right here. Cotangent is also the same thing as cosine divided by sine. And this is 1 over sine. So when sine is 0, both of these should be undefined. When sine is 0, both of these should be undefined. So that works out. All right, so secant, it's the reciprocal of cosine. So that's 1. 2 root 3 over 3. Root 2. 2. Undefined. And then I'm in the negative territory here. Reciprocal of 1/2 is 2. So negative root 2. 2 root 3 over 3. Reciprocal of the negative 1 is negative 1. And I'm checking for like my reflection, not counting the signs. And by the way, these should be the reverse of each other. Undefined 2 root 2, 2 root 3 over 3. Undefined 2 root 2, 2 root 3 over 3, 1. So again, these work opposite directions. So you can check your work. I always like to check my pi's over 4s. Root 2 over 2, 1, 1. Root 2 over 2, root 2 over 2. 1, 1. Root 2 over 2, root 2 over 2. And then check the same thing here. And then double check that the only things that I have positive over here are cosecant and sine. And, you know, that was, I don't know if that was 5 minutes or not, but just practice doing this several times and check your work. And you might have better patterns that work for you. And then that takes us to, you know, the stuff on the last problem where you have to get these trig values kind of instantly. So what you want to do for these is you want to have a system for your brain to use. Now, maybe you're somebody who can literally memorize not only quadrants 1 and 2, but you can memorize quadrants 3 and 4 cold. My brain's not quite that strong anymore, so I have to use a little bit of a system. So when I see sine of 7 pi over 4, I know that any pi over 4, whether it's pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4, is going to be root 2 over 2 for sine and cosine. Then I start to think of my quadrants. What quadrant is that? Well, it's almost twice as much. So that's going to be quadrant 4, and sine is negative there. Tangent 11 pi over 6. Well, every tangent of something over 6 is root 3 over 3. We're in quadrant 4. Only cosine and cosecant are positive there, so that is a negative. Cosine 4 pi over 3. Well, I haven't memorized any cos of something over 3 is 1/2. And 4 pi over 3 is quadrant 3. And in that quadrant, cosine is positive. No, it's not. It's negative. Very good. And that's just the logic that I'm using every time. So first I look at the trig function and then the denominator to get the value that goes here. And then I look at the quadrant to get the sign. Okay, and if you want to make yourself flashcards, I think that first step is getting really good at this. Then when I make flashcards for this, because in calculus what you really have to do is be fast with all these values. Like I just made one of these for all 6 trig functions, etc. Until I had all 6. And then I took all the radian values and I made one card for each, all the way around the unit circle. What's pi over 6? Then what is in there? 5 pi over 6. 7 pi over 6. 11 pi over 6. And then I made it for all the pi's over 4s. So all 4 of those. Until I had all the values from the unit circle here. And so then I just draw one of the 6 function cards and one of those cards and see if I can get it. And that's just a way to really sharpen myself. And whether you have time to do that and time for this quiz or not, I don't know, but you want to do it probably before the school year, because I'll hit you hard on getting all these learned in a pretty fast way. We have to understand how the functions work, how the unit circle works, how the triangles work, but it's also really important that we're able to grab these values whenever we need them without taking a lot of time. Whew, that's it for this one.